This is part 2 of our video, and I'm inside the house at my electrical panel, and the monitor on the left is showing our current wind speed, and it's about 13.6 mile an hour up on that anemometer, and this voltage meter is giving us the voltage at that wind speed, and this is with our rectifiers hooked in parallel, and that's part of the versatility of this dual armature unit. If you got a good wind resource, you can hook it in parallel and get double the amperage and still get 12 volts, and it's performing pretty good for us today. We're getting a volt or better per mile per hour of wind speed. Now in a real light wind, you can hook these in series and you only get half the amperage if you do when you have them in parallel, but you pick up your 12 usable volts at about half the RPMs. And in a minute here I'm going to wire these up in series and shoot another part 3 of this video showing the kind of voltage we're getting today at this wind speed with them wired in parallel. Now, air density has a direct effect on the amount of torque that you're going to get out of wind turbine blades. So this is not a constant. This doesn't mean that this is the volts that you're going to get at this wind speed all the time. It's going to change. There you can see it dropping off now where it's in between gusts, but it's fluctuating between 9 and 18 to 19 volts, and we're running 10 to 13 volts on our wind gusts. We've had wind gusts today up to 18 mile an hour and calms of about 6 mile an hour. Shortly here we'll show you part 3 of our video.